Good afternoon, Professor.
Good
Good
afternoon.
afternoon, Professor.
Good
Good
afternoon. I love it. Well, it's like I'm getting better and better. Good afternoon, Caroline. Good afternoon. I think that was Amy. Good afternoon. I think that was Savannah. It goes so fast now that I can't even what I think. Good afternoon, Amanda. Good afternoon, Caitlin. Now I'm going to the chat, but I love it. I love it. I appreciate it. See, it even, you have to admit, Caroline, it even improves your mood. Admit it. I'm just kidding. But I mean, I think, I hope. All right. Well, there's more people coming. Okay. Not that you're in a bad mood. I'm not saying that. Why would I even know? I'm just saying. Okay. Good afternoon, Alicia. Good afternoon, Jamalette. Good afternoon, Amanda. Good afternoon, David K. Good afternoon, Kevin. Happy Halloween, Kevin. Good afternoon, Kimberly. Good afternoon, Caitlin. Good afternoon, Chloe. Good afternoon, Amy. Good afternoon, Sophia. Good afternoon, David P. Whoop. Good afternoon, Adon. Good afternoon, Amy. Hi, Christina. Good afternoon, Elda. All right, in the house. Physics is in the house. Actually, physics is in the house thanks to COVID. Okay, so that's Caroline. That's Amanda, Savannah, Elda. Awesome, awesome. Kevin Lynn. Okay. Oh, did I not say? Did I say Amy? I think I said Amy. Oh, did I never notice until now? Oh yeah. So first, I never noticed. First, I like totally. Hello, Caitlin. First, for months, I don't get the whole Amanda Caitlin thing because I'm an idiot. And then also today, or I don't know why, but then today, and I'm sure they love that I can keep bringing it up. Okay, but then why am I today for the first time noticing that we have two Amy's? How did I not? Okay, I'm sorry. I mean, I know both the Amy's. I never just realized that there were two. Okay, anyway. And you ever notice you never see me and Clark Kent in the same room at the same time? You know what I'm saying? Okay. You never see me in a room at a time, actually. But come by and visit on Tuesdays, please. 4th floor. Okay. We're gonna do stuff. We got to do stuff. We're gonna do stuff. Well, okay. We're moving on finally in the material. And we do have to. We have some academic things to talk about, which we will in a minute. But material-wise, physics-wise, we finished that big old duck problem yesterday. Yes. I mean, as always, I was like rushing a little bit at the end, but I think we totally got answers. You should stop and look at, if there's anything that was unclear at the end or too fast or anything, or if you had a chance to assimilate it and you want to ask anything now about the big old duck, please do. I mean, it's not the last time we're ever going to say anything about it, but I think that more people coming. Sorry. But in my mind, we finished going over the big old duck. And it just happens to be a problem that just happens to be called the big old duck. But what's the real point of it? The point of it is the same point as the point of lab 4, which is that things are happening in 2 dimensions. And the way to solve the problem is to realize that when things are happening in 2 dimensions, that just means that things are happening in one dimension, and things are happening in another one dimension. And those 2 sets of things that are happening independently, yet simultaneously. I'm going to say that for the rest of my life. Again, this is another implication of Galileo's principle. I'm going to keep saying that phrase the rest of my life, like all phrases in physics. It's meant to seem like totally reasonable when you first hear it. It's not meant to be confusing or intimidating or sophisticated or complicated, but it's a little sneaky because it actually almost seems so reasonable and obvious. It doesn't sound like it's saying anything, but it really is saying something very productive. That is when I say independently yet simultaneously, which I will say about multidimensional spaces for the rest of our life. What I mean again is that each axis does not affect the other axes. So each axis can be treated by itself with one-dimensional equations that we now have fully developed. And each axis can be treated as though whatever was happening there in that axis is the only thing happening. In other words, the axes don't interact with each other. This is like a very fundamental sort of not even discovery of physics, but kind of presumption of physics, that each axis of space does not affect any other axis of space directly. therefore, we don't have to develop any more equations for kinematics than the ones that we have for one dimension at a time. Yet, things can happen in more than one dimension. Although they happen independently, they can still happen simultaneously. They can still happen at the same time. So that time, lowercase t, can and should be the sort of link between everything that you solve for in each of a multiple set of dimensions for a multiple dimensional problem. So that's what we're trying to see in Big Old Duck. That's the summary of it. Once you see that, it's easier to solve that problem than otherwise, but it is a thick, long problem. I'm not going to go over lab 4 right now. We might get a chance to talk about it in lecture, but I'm just my summary of lab 4. And I know I'm pretty sure you've already actually done your report anyway. You can confirm or deny that. But the big takeaway of lab 4 is another version of that same thing. Like you fire the gun off the table and it's going forward, falling down. So it's going forward while it falls down and it lands on a spot on the ground, and you're supposed to, determine, you're supposed to either be able to predict where it's going to land on the ground, or maybe better, if you're like a criminalist, what we're really thinking is, okay, given where the ball lands on the ground, where should the gun have been placed in the first place? I mean, it's a subtle distinction, but basically we are either predicting or retrodicting the horizontal displacement of a projectile that travels vertically, right? It's a two-dimensional problem. I'm not saying it's exactly the same as Big Old Duck, but really it is the same as Big Old Duck in that you have free fall acceleration along the vertical axis while you have zero acceleration along the x-axis. And just like Big Old Duck, what you do in lab 4 is using the height that the bullet got fired from, like knowing the height of that table, that lab table from which the ballistic got fired from, knowing that height, you figure out the time that it would take the ball to reach the ground. And then you believe, okay, whatever amount of time it would take for the ball to reach the ground, well, during that exact time, the ball is also going forward. Like it's going forward while it falls down. The two accelerations, the two phenomena are completely independent, but they are happening at the same time. So you use your knowledge of free fall, constant acceleration to solve for the time along the y-axis, and then you say, well, that must be the same as the time along the x-axis. So you ask yourself, given, and you know the initial horizontal velocity of the ball, the initial x-axis velocity of the ball. So you say, given this time that I learned from the y-axis, and given this initial velocity applying in the x-axis, how far will the ball go in the x-axis? It really, it is Big Old Duck. And if you see that, if you even, there's no way you could see it while you were doing the lab for the first time, or there's maybe very little way you would notice that while you're solving Big Old Duck for the first time. But if you're hearing me now, if you see like, oh, if you start to see, oh, I guess those are kind of the same problem, even though they're all dressed up differently, then you're really getting something in physics. Like they really are the same problem. And last, I'm just looking at this question, but you're welcome to ask me about this at any time. The last thing about that, well, or two more things about that. I'm just worried I don't want to get on a tangent, but two more like takeaways from Big Old Duck and from Lab 4. The two takeaways are, one, notice when you solve for the time along the vertical axis, because there's an acceleration, i.e. lowercase g, like 9.8 essentially, or 10, whatever, because there's an acceleration and because there's also an initial velocity along the y-axis. So because you have an equation like y equals 1f at squared plus v naught t, and like none of those are dropping out, none of those are being canceled for 0, what you have there is a full actual quadratic equation, right? Like we noticed this, well, oh, excuse me. It is a full-on quadratic equation. Actually, to be fair, in the lab, the initial velocity is 0. So it's actually not as hard an equation to solve. You don't actually need the quadratic formula when you do it in the lab. If you're with me, then you're with me. But in either case, it is a y equals 1FAT squared situation. So that when you solve for t, particularly in the big old duck problem, you're forced to use like the quadratic formula or factor the equation or do, complete the square or something. And you find that there's two answers, right? That's just an interesting thing to know. Now, in the lab, there aren't two answers because the thing is already falling down, but and it doesn't have an initial. Technically, even in the, well, I don't want to get into all of this. Technically, there's even two answers from the math, even in the lab. It's just that one of them, since you're in a lab and you're looking for something very specific and very physical and you already know what you're looking for, one of the two answers you don't care about. But the math does spit out actually two answers. One of them just happens to apply to a time that occurs before you're even doing the lab, so it doesn't matter to you. But anyway, point one is notice that once there's acceleration, then position is a quadratic function of time. So anything you know about quadratics from math, including parabolas and all that, do apply. That's point number one. Point number two, point number two is just also note, if you really believe what I'm saying, if you believe the big principle here, that a two-dimensional problem is really two one-dimensional problems occurring independently yet simultaneously, if you really believe that or see that, and if you really know what you did in lab 4, if you really understand that you solved for the time on the way down and then use that for the shot out, if you think about it, you got to realize that when you solved for the time on the way down in lab 4, the time that it would take the ball to fall that height of that desk, you did that independently. You just plugged into the equation y equals 1/2 AT squared plus V naught T, and then you said V naught was 0. So you didn't take into account in any way that the ball was shooting forward when you solved for the amount of time on the way down. You did not incorporate any horizontal fact when you solved for the vertical activity. And that's correct. You shouldn't have, like, if you're believing all this and doing this right. But if you did it correctly and did that, notice what we're really saying then is like the amount of time that it takes that ball to fall down to the ground has nothing to do with its horizontal motion. It means you just treated that ball as though it were just a ball that just got dropped. In other words, and I think they ask about this at one point for you to consider during the lab and during your report. I just want to highlight, like, this is not a small point. If you did that lab correctly at all, or even if you understood at any point what you did in that lab, even if it was once you wrote it up, then you got to, then you understand that actually what you're tacitly believing, what we're all tacitly believing when we do this, it is that if I stood somewhere in front of y'all, if I stood somewhere and I had a bullet in my hand, right? And in my other hand at the same height, I had a gun, like aimed fully forward, like aimed at a purely horizontal angle. And I said 1, 2, 3. And at 1, 2, 3, I dropped a bullet, and at the just like dropped it, released it from my hand, and at the very same moment fired a bullet from the other gun, from the gun that's in my other hand, right? If I did this from the same height and I did it at the same time, and there was no tricks up my sleeve, no angles or anything like that, but if I just went 1, 2, 3, and I just dropped one bullet and I fired the other bullet, I don't care how fast I fired that bullet. It could be 600 miles an hour. But if you're believing or you're understanding everything that we're saying about big old duck problem and lab 4, then what we're saying is both of those bullets should hit the ground at the exact same time. I just want you to think about that for a minute. I mean, just like let it sink in. And certainly if you have any objection to that or question or anything, like put it in the chat, like for real, but just for a minute, think I'm literally saying, and I'm saying this is true. Like if we weren't in a Zoom class or I with you, like we could demonstrate this in a class, or you could demonstrate this in the actual real world. Like if you drop something and you fire something forward, I don't care how fast you fire things forward, they'll hit. So one thing will just go straight down and the other will go like, woo, and like go all these miles and miles, like before it hits the ground. One will cover a huge amount of horizontal distance before it ever hits the ground. But it will do that in the exact same amount of time as the one that was just released. Because what we believe is that the acceleration due to gravity applies to the y-axis independently from whatever's going on in the x-axis. So they both take the same amount of time to fall to that obstacle in that y direction. They both behave the same way in response to the vertical acceleration due to gravity. But meanwhile, one of them just happens to be doing something horizontally while the other isn't. But they'll hit the ground at the same time. And I don't think that's obvious. That's why I'm saying it. And maybe you've heard it in high school. But if you didn't ever hear it before, I am not saying that's obvious, like duh, like we should all just, of course, realize that. I'm saying it's not obvious. It's a surprise. I wouldn't have thought that. That makes my brain hurt the first 400 times I think about it. It's not what I would come up with. But when I think this all through and realize what I'm doing, not only do I think it's true, but I think it absolutely is implied by any of the work I did. Like I couldn't have gotten lab 4 right or big old duck right if I didn't tacitly believe that. So just like let that sink in for a second, or see, and if you have any questions about it or whatever, or I'll just do my stupid thing. Could you just like give me an electronic thumbs up if you just like heard what I just said, and like whether you like it or not? Do you get what okay, thank you, Felicia. That's awesome. Thank you, Chloe. Thank you, Alicia. Thank you, Christina. Thank you, Amanda. Thank you, Caroline. Thank you, Amy. Thank you, Caitlin. Thank you, David. Oh, even thank you, Christina. Thank you, Chloe. Okay, I love what you guys do. Okay, thank you. And thank you, Amy. Did I say, or both? Okay, so you get, okay. So that's just one of those weird physics surprise. Like it's just another example of how physics, I think physics, what's cool about physics to me, why I do it, is that every step along the physics path is like, well, not every step, but tons of steps along the physics path are like unexpected, but then sensible in retrospect, which is also exactly why physics is hard, right? Because it always makes sense after the fact. It always seems like it should be like, oh, yeah, I should have thought of that, but it never is. It's just, but it's logical. It's just surprising, I think. But okay. Now I want to, there's a next, so what I want to do now, oh, sorry, someone's here. What I want to do with all of this, that was all like an intro to the principle that allows us to navigate 2 dimensions of position, or of displacement, or 2 dimensions of velocity, or 2 dimensions of acceleration, etc. at the same time. What we now need to introduce is like an actual mathematical technique that advances things, called vectors. Again, of course, many of you may have seen vectors in high school or in some other class. Like we're going to do them in a specific physics way now. Well, so I have a new sheet that we're going to start together, like we have done before, and then it'll be due. It hasn't been posted yet, but so we're moving on to vectors now. If you're trying to follow what we're doing, at all, no, but if you're trying to like cross-reference ever what we're doing with any textbook, there's no, you don't have to have a textbook in this class. I don't know if you noticed that, but like if you're ever trying to just follow along, or on a Khan Academy of video, or like anything, like technically now we're in 2-dimensional kinematics. It's like we've been in 1-dimensional kinematics for a while. Now we're in 2-dimensional kinematics, i.e. vectors. Like if you ever wanted to look this material up anywhere, you would look up under two-dimensional kinematics or vectors. That's what we're about to do. Specifically displacement vectors we're going to do first, and then velocity vectors. I'm going to give you a problem in a moment, and we're actually going to work on it in breakout rooms for a little while. Like it's not assigned. It's like a warm-up starting problem. Actually, I'll start writing it now. And you're going to work on it for a little while in breakout rooms, and then we'll talk about it. Hold on, let's look at the time. Yeah. Well, yeah. All right. So let me draw it. I'm going to give it to you. And then this is always like a weird thing. You're going to have to bring the sheet in with you to the breakout room somehow. So I'm going to draw this. I'm going to ask you to copy it down in your own notes or in your own way, because it won't stay on the screen in all the breakout rooms. So bear with me for a second. wait, I keep saying, yeah. Okay. Okay, so this is a little bit illegible as always, and welcome people who just joined. All right, so this is you're going to want to copy this down. That I'm going to read this out loud. I'm going to try to make it clear. It's a little bit illegible. You're going to copy it down. You're going to bring it with you into a breakout room. You're going to work on it in a group for a while, like just this one problem, but long enough to give you time to try different things, but then short enough, hopefully, for us to come back and for me to show you my solution. I'm going to read the problem out loud in a second. Again, this is an example. This is in a way out of nowhere. Well, no, it's not. The truth is, this might remind you of lab 3, which we've never explicitly discussed in class yet. In lab 3, you did, it was like not really a lab, it was like a piece of graph paper where you're drawing arrows, and the arrows represent displacements in 2 dimensions. And each of the arrows is ultimately known as a vector of displacement. They represent these vector quantities that have magnitude and direction, et cetera, et cetera. But so you do this stuff in lab 3, and then I believe at the end of lab 3, although it changes from semester to semester, but I believe you might have even been given like a sort of practice or theoretical problem that you maybe even had to write up in your write-up. And it may have looked a little bit like what I just wrote here. So you might have practiced something like this before. That would certainly give you a leg up today. That would be great. On the other hand, I'm not actually, sorry. Oh, sorry. What did I? What did I? Wait. Absolutely right. Oh my God. Thank you. Thank you. Nice. Wow, Kevin. That's awesome. Yeah. Yeah. Oh, and thank you, Amanda. Oh my God. No, you're totally right. Thank you guys. I love this class. You are totally paying. I did not do that. You are totally paying attention. Thank you. I did not do that on purpose to see if you're paying. Thank you. That is a great correction. All right, hold on a second. Thank you. Both of you. All of you. Thank you for being such good people. See, who says that? See, even after COVID, some of us are still not criminals. Some of us, not me, but okay. Thank you, Amanda, and thank you, Kevin. Yeah. So for anybody who wasn't Amanda or Kevin, there, please, there was a correction that, there was a correction that was just made. I'm going to address it anyway when I reread the problem. But anyway, this problem that I'm giving you, you might have a leg up on it or some background comfort from lab 3, or you might not. Like everything in physics, I'm actually asking, I'm asking this question because I think it's the next natural or logical step from everything we've been doing so far. In other words, this is not like assuming that you read some formula or some rule in a book, or like this is not a practice in some new piece of knowledge that someone had to present to you in order for you to do this. This is physics. So the theory is that this is that with everything we've done so far, with a little stretch of our brain, we would be able to move ourselves to this new application, right? And again, the whole goal of physics ultimately is that we learn enough fundamentals that we can just always do that next step without having, which is one of the reasons I just don't use a textbook anymore, to be frank. But anything you have ever seen, like lab 3 or high school physics or something, could be helpful here. So what do I mean? So you're going to work on this and you're going to help each other. Now, what do I mean by here? What is the problem? The problem is the problem that Kevin and Amanda, I think it was just caught. What I'm saying is this: picture that you walk 5 miles to the northeast, but specifically 30 degrees to the northeast. What do I mean by 30 degrees? What I really mean by, I mean, if I just said northeast, like an English or American speaking person, if I just said northeast or due northeast, I would literally mean sort of equally distant between north and east. Let me back up. If I say due east, if you picture on a coordinate system that north is like this, south is like this, east is like this, and west is like that. Now that's just a coordinate system on a piece of paper. That's just a choice. But if you label that, if you picture that east is to the right and west is to the left and north is up on the page and south is down on the page, then you can picture like a little unit circle in that, or you can picture you can picture a reference axis and a pointing axis, sitting, like a reference axis always sitting on the positive x-axis on the east pointing line. I'm making this way too complicated. What I'm trying to say is, from here on in, if someone says due east, I consider that 0 degrees. If someone says due north, I consider that 90 degrees, right? Okay, east, 0 degrees. I'm opening up an angle within the first quadrant, like the way you always do in math. I'm opening up a positive angle. So if I went all the way straight up to the north, I would consider that 90 degrees. If someone said due northeast, like northeast, if they just said northeast, I would consider that right in between east and north. I would consider it 45 degrees. In fact, to be a little bit more specific now, I would, if they say, but if they said something like this, like 30 degrees northeast, what I mean is I'm going a little bit more east than I am going north. What I specifically mean there, here's the part you might have known, you might not have. If I say 30 degrees northeast from now on, what I actually really mean is 30 degrees north of east. That's what I actually mean. I mean that you start, you picture a little reference line at east and you open it up to the north. So 30 degrees northeast really means 30 degrees north of east. You might even want to make a note of that if you've never thought that through before. Similarly, 30 degrees southeast, which then the other vector is 30 degrees south of east, okay? If someone ever, you could therefore say something like 30 degrees east-south. I mean, it's awkward and it's not the way most English people like speak, but in physics, you could say something like 30 degrees east, south. And if you're following me, that would mean the same thing. 30 degrees east, south, if you're following what I'm saying, would mean the same thing as 60 degrees southeast, right? I hope you're following that. Okay, well, what's the point of all this like background is we're now in two dimensions. We're dealing with vector quantities such as displacement. We're dealing with quantities that have both magnitude and direction. But now direction has to be a little bit more specific than it ever was before. It is still true that on each individual axis, you have plus and minus. Still true, still really important. But it's equally important for me to say plus and minus only refer to what's happening on each independent axis. From now on, I'm never going to say something like, if I'm in two dimensions and someone says, what's your direction? If I say it's positive, I don't know what that means. It could be positive with respect to north and south, or it could be positive with respect to east and west, and it could be both at the same time or whatever. So when we're trying to give an overall direction for two dimensions, from now on, we have to use an angle and points of the compass. None of my angles will ever be negative. I know you could do this differently in different math classes and stuff, but from here on, any direction can be fully specified with some acute angle and some points of the compass, any angle, okay? So, you know, it's going to be 20 degrees south of east or 20 degrees north of west or whatever. Those are directions. Okay. But I think you know that, but I'm just trying to be clear. So let's say here in this situation, I walk a displacement of 5 meters. That's my magnet. Oh, sorry. Oh, good. I love it. He's back. Awesome. Oh, and there's something else in the chat too. Sorry. Oh, cool. Felicia, thank you. Sorry. Okay. I didn't even see that. She's back. She's always back. She's so back. She's front. Okay. No, thank you both. Awesome. Right. So we walk 5 meters at 30 degrees northeast. That is a vector quantity now. It has a magnitude and a fully specified two-dimensional piece of direction, right? And now that we're in two dimensions, from here on in, we represent our vector quantities with these objects called vectors, which are arrows. The length, and you might want to write this. I don't have this written right here, but if it's not, from now on, we use an arrow called a vector to represent a vector quantity. And when I say represent, what I literally mean is from now on, the length of the arrow will represent the magnitude of the vector quantity. Like once we pick a scale and everything, and then we do everything to scale, right? So an arrow that's twice as long as another arrow would literally mean a vector quantity of twice the size of another vector quantity, et cetera. So we use arrows to represent vector quantities. The length of an arrow represents the magnitude of the vector quantity, and the orientation of the arrow, i.e. the tip tail, where the tip is and where the tail is. The tip tail orientation of the arrow represents the direction of the vector quantity. So from now on, we're going to draw these little arrows, and we're going to move these arrows around the page. And if we draw them properly, and we draw them to scale, and we draw them carefully, and we move them around the page in a certain kind of way, we're literally going to be able to use these little arrows as calculators. Like by making pictures of these arrows, we will literally be able to compute various combinations of vector quantities. Again, some of you have seen this, some of you have not, but that's the idea. And now we're using arrows for the first time because now we're applying our vector quantities to higher dimensions. Okay, I'm talking way too much. Oh, just for a small change in pace. So here's the problem: is you walk 5 meters, 30 degrees to the northeast, and then from where you ended up, like so you start at position A, you walk all the way to position B, 5 meters, 30 degrees northeast. Then from position B, let's say you now walk 8 meters at 60 degrees south of east. And what I want to know ultimately in this problem, just like you might have seen in your lab, what I want to know is if you do that, what is your overall displacement, your final position, like the difference between your final position and your initial position? Like, where do you end up relative to where you started? I want to know overall displacement. And this is what you're all going to solve in the breakout room in a second. But I want to know, but that means displacement. So what I want to know, I mean, stupidly, the question's like on the side here of the page, but I want to calculate the total displacement. I want you to, in other words, add those two displacement vectors somehow. I want you to figure it out. Just think it through with every principle that you know so far from the class. But when I say I want total displacement, what I really mean is, in the end of the day, I want an arrow. I want an arrow somehow whose length represents how far you walked in total from your initial point A all the way to your final point C, right? I want an arrow whose length shows me that, whether it's, 13 meters or 11 meters or 21 meters or whatever. And that arrow, which should point in a particular direction, like you're going to be able to tell me at the end of the day, did you end up walking like 20 degrees northeast or 40 degrees southwest or what? Like I want a magnitude. So in other words, I want an answer that's of the same form as the original two vectors. Those are displacements. They're going to be added together, and I want a total displacement. Now, this is this is a simple, straightforward problem. I mean, it's simple in that what I'm just asking is, given two vector quantities, can you add them together and get me a third? Like, can you add two vectors? It's simple for me to say. I mean, well, apparently it's not simple for me to say because I'm taking 45 minutes to say it. But I mean, it's straightforward, hopefully, to consider. But I'm not saying that it's a joke to solve. I'll tell you right now that the answer is not 13, for example. Like, you're going to be adding these two vectors together, but you're going to get a vector whose length is not 13. It's not just a matter of adding 5 and 8. And you're not going to get a vector whose final angle is 90 degrees. You're not going to just add 30 and 60. You're going to have to think about it like a little bit more rigorously than that. So and you can use any method you think you discovered in lab 3. I highly recommend you use the principle that I'm saying, that every two-dimensional situation is really two one-dimensional situations. You can use any equation we have so far. I don't think you're going to have to use, I mean, there's no acceleration in here or anything like that. So you're not going to have to use any complicated equations. There's not even velocity. These are just displacements. But you can also use any math that you ever know from any math class, such as any math that you know about, I don't know, right triangles. Anything you know about right triangles, like, I don't know, hint, hint, pause, everybody listen who wasn't listening before, hint, hint, like SOHCAHTOA, is that fair game? Oh, yes. Like, are you allowed to use it? Oh, yes. Would I recommend that somehow it comes into your solution? Oh, yes. If you try to get a solution without SOHCAHTOA at all, you might not be barking up the correct tree. Might your solution involve something like Pythagorean theorem? I think it might. Like, now, but make no mistake, by the way, am I implying that right triangles will be involved in how you think about this? Yes, I'm strongly implying that right triangles will be involved. But am I saying that because I think if you put these two arrows together, you get a right triangle? No, that's not why I'm saying that. Like, maybe by coincidence you do, since I gave you a 30 degree and a 60 degree, but that's not, I'm not saying, and this is a big warning because people do make this mistake all the time. I am not saying that you should form a right triangle by putting those two arrows together. In fact, I'm saying that would be a common mistake. The things are a little bit, they're not that simple. But I am saying that your knowledge of, so don't just put those two arrows together and form a right triangle. That would actually be a mistake. But I am saying that any of your knowledge of right triangles from math class definitely is involved here. Why? Because the x-axis and the y-axis of space are at right angles to each other. And every two-dimensional problem is really two one-dimensional problems happening independently yet simultaneously. So in a minute, this is the problem. So in a minute, we're going to break up. Breaking up is so hard to do. Sorry, we're going to break up into break up rooms or breakout rooms. Sorry, and you're going to do this problem. What is going on? Oh my God, my computer's going crazy. First, before I break you out, can I just get electronic hands that you get what the task is going to be, that you get what's going on? Awesome. Oh, thank you, Amanda. Thank you, Kevin. Thank you, Caroline. Thank you, Amy. Thank you, Christina. Thank you, Jamila. Thank you, Chloe. Thank you, Felicia. Thank you, Caitlin. Thank you, Sophia. Thank you, Alicia. Thank you, Nicholas. Thank you, Elda. Okay, cool. Thank you, Samuel. Thank you. The only problem with me doing this, then I feel like if I accidentally say everybody's name except for one person, then they're going to be scarred for the rest of their life. Okay, because I'm that important in their life, right? Okay, so cool. So it's clear. So we're going to do that. But there's one other item of business that's going to happen before I break you up. And this is on purpose, not to stall any further. And wait, let's look at the time. If I'm either going to end up giving you limited, you might not end up spending that much time in the breakout room. You might not even get to, some of you might not even finish. And I apologize for that in advance. And it's okay. It's not a test, obviously. But speaking of that, here's the other reason you're going to go into breakout rooms, even if it's for a limited time. I want to put something in your mind for you to talk about privately without me in the room. We do need to have an exam. I mean, we need to have a midterm exam. So I'm going to give you my thoughts on that, but then you're going to discuss them in private in the breakout rooms. And when we come back, we're going to reach consensus on this. Even it, my God, my computer. So this is the problem that's on the docket right now. This is your job to discuss in the breakout rooms, but I'll warn you right now that even if you don't finish it or somehow or something, that's okay. That's okay. But I think we all kind of, and I know nobody wants an exam. Certainly I don't, but we kind of do need to have one. And I'm sure that since we have to have one, you'd rather know what's going on with that than not. I also think that you should have input into it. So we're also going to use the breakout rooms for this purpose. So hear me out for it. So I hope so I'm mentioning the word exam. So hopefully I really have everybody's attention now. Okay. This is how exams work in this class. What happens? Well, okay, I'll give you I'm going to give you a proposal for the timing. You're going to adjust. You're going to like check with each other and see if the timing works for you. And if it doesn't, you're going to come back and give me a counter proposal for the timing. Okay. Like I want to make sure the timing of it works okay for you. Like honestly, especially since like you didn't know it tonight and you have to plan and all that. But God, my computer's going crazy. So I'm going to give you a proposal for the timing, but let me give you an idea of what that timing entails, what it means when we have. Okay, when we have an exam in this class, what happens is it gets posted on a certain night, like on a Thursday night. The exam will get posted. Wait, everybody's listening right now, right? Okay. It gets posted on a Thursday night around 8 p.m. It's a take-home exam. You take it home, like it gets posted in Google Classroom as though it were just a really big homework assignment or whatever, or like 3 homework assignments put together or something. It gets posted on Google Classroom on a Thursday night. You take it, you download it, and then it's due back, and then you do it in your own way, in your own time, not under test conditions, not under timed conditions. You take it as though you were like writing an essay or something, like all weekend or however you want. You take it at home and you submit it. Usually in this class, since we meet on a Monday and Wednesday, you would submit it like a minute before class, 12:15 on the following Monday, probably. Okay, that part we could maybe adjust. I can negotiate. It could be the following Wednesday, maybe, or something like that. But usually you then submit. So you have a full weekend to do it. And it's not this weekend. There's more advanced warning than that. It's not this weekend and it's not Halloween. But the way the exam works is it gets posted on a Thursday night. You have a extended weekend to work on it. You don't work on it in test conditions. You submit it a minute before the next class period, and then you do show up to class. Like class is part of the exam requirement, but you show up to class, you've submitted the exam, you don't submit the exam late, and you don't cut class, and you certainly don't cut class to work on the exam because that's totally unfair to your colleagues. So you submit, so the exam ends once you've submitted it on time before class, and then you sit through class where we do new material. And during that entire time that you're taking the exam, during that weekend, two things. Usually what will have happened is there will be a week before then where there'll be a practice document that you'll see, in other words, a draft of the exam. You'll see a draft of the exam like about a week earlier than that, and have a chance to work on in your own way, trying to solve the draft exam. And you don't hand it in, you just use it as practice. And then there's usually at least one class where you can where we spend the class with you asking me questions about the draft practice exam, and I answer. In other words, that's our review class. So there's a practice exam that doesn't get handed in and is not for a grade, but helps you see what the exam would really be like. Then the actual exam is posted on a Thursday night and due back Monday. And the actual exam is usually remarkably similar to the practice, not exactly identical, but meant to be very, very similar. The practice is just that. It's a draft of the real exam. And then like some numbers are changed and things like that to make sure you really know what's going on. But the practice exam is the way you study for the exam. Like you don't go out and buy a textbook or start reading, blah, 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 blah. Like, so you prepare for the exam by taking the practice exam and then asking me questions about it. And then the actual exam looks right. Okay, good question. I see a question in the direct chat. And then as to that, usually what happens, so there's a question in the exam about like, will there be like answer sheets or explanations to the practice exam, which is a very fair question. And usually what I do there is I usually post a bunch of solutions to I usually post a bunch of solutions and answers to the practice exam. And anything I post, and I answer questions about them, like in class before you take the actual exam, and anything I post, then when on the actual exam, like then I'll like change the numbers slightly and stuff since I posted the solution. But anything from the practice exam that I don't post, if I don't give you a solution to some question on the practice, then what that means to you is then I'm not even going to change that question. That's going to be the exact question on the real thing. So instead of having an actual solution to it exactly, you just have tons of lead time to figure it all out and talk to each other and all that kind of stuff. And I'll still answer questions about it. But so basically, yes, I basically post solutions to most things on the practice, but anything I don't post, but then those things are changed slightly for the real thing. But anything I don't post is a signal to you that exact thing will just be verbatim on the real thing. So you sort of have so there's like costs and benefits both directions. Now so I'm saying all this because we've never had an exam yet. I know that, and it's a little bit later in the semester than maybe some of us would have liked. I don't know. But this is how midterm, and you're only gonna have one of these, and then you'll have the final. Okay, and we'll talk again later about how all the grades work and all of that. None of this is meant to scare you. Everything is meant to try to not trick you and to make things as clear as possible and to give everybody the best chance as possible at an A. That's still always the philosophy of the class, is that I want as many actual earned A's as possible. And I want you not to be competing with each other. I want you to be helping each other. So the last thing to answer the private chat person's question about, so I'm sorry to take so much time on this right now, but like it's kind of time. We have to start gearing up for this. So the one other thing, so someone just asked, like, will I give solutions to the practice exam? And the basic answer is yes. The other thing to me super clear is that the actual exam, once it's posted on Thursday night and then due back the following Monday morning, or Monday 12:15, that actual exam that's posted, which is take home and not timed, let me also be explicit. And I hope you're hearing me. It's also open universe. The actual exam is open universe, meaning open internet, open notes, open your past homeworks, open colleagues. Serious, and there is a catch. If you're hearing me correctly, you might be thinking, wait, there's got to be a catch. If you think that, then you are hearing me correctly, but it's not a bad catch. But I am saying that not only will you get an advanced draft sneak peek at the exam so that you won't be shocked when you see it, so that you'll know how to prepare and know what to expect. But then the thing that you'll actually get on the Thursday night, you can and should work with each other and the world to help each other get through it. I am saying that, and it's not because I'm an idiot. I mean, I might be an idiot, but that's not the reason I'm saying it. I'm saying all this partly so that because we do have to deal with an exam, and I hate exams as much as you do, but we have to have it, and it is real, and I'm not saying it's going to be a joke, but I don't want there to be any more stress associated with it than is already just necessary. So I'm used to, at this point, giving open universe exams. I have a lot of reasons for that. We're going to talk more about why I'm not crazy, because I know it's crazy, or I know it seems crazy. But what is the catch? Like, so I am literally telling you all that when you get this take-home exam, you literally can talk to each other even during that weekend about it. And in fact, not only am I saying that you can, I'm secretly hoping that I'm unsecretly hoping that you do. What's the catch? Like, how could I possibly be so stupid as to be doing this? The catch is that when you finally go down, sit down to write out your final copy to the exam, to the solutions, to the problems in the exam, and the exam kind of will just feel like 3 big homework assignments, like 3 big problems, with a diagram at the top and with like part A, part B, part C, like that kind of thing, like that you're used to seeing. When you sit down to write out your solutions using the 5-step method and showing all your work and showing diagrams and being really clear and showing your full process and your full understanding and knowing that you're going to get points for all that process and all that work, even if answers are wrong and yada, yada. When you sit down to do that, at that point, what you're writing down is everything and anything that you actually understand. I don't care where you got it. I don't care if you just learned it from your friend 5 minutes ago, literally. In fact, then I love your friend if you did. But by the time you write it down, you're writing down only things that you understand, not things that you're copying or directly or something, or that some other friend wrote for you. And your goal, and because the catch of this whole process, and I've been doing this for a while, so I promise you it's not because I'm naive. The catch of the whole exam process of doing an open universe exam like this is that you have to know that I know that we're doing it this way. So I know that I will have already given you solutions in a practice exam and a practice exam. And I know that the answers to all these questions are somewhere on the web, somewhere, probably, even if I didn't give them to you, and that your friend has the answers and all that. So clearly, I'm not just looking for correct answers. I'm very much not, in fact, just grading you on correct answers. Because that would be stupid. That would be stupid. What I'm looking for, what your actual exam is not give me correct answers. Your exam is prove to me why the correct answers are the correct answers. Like every one of your solutions is a full solution, a proof, as it were. That's why we've been practicing the 5-step method and everything. You're trying to explain and show as thoroughly and clearly as you can why the answers actually do make sense. And better than that, you're trying to show or prove that you see the sense that they make. So your goal in the exam, what you're really being examined on is, can you show me that you understand the physics, that no matter where it came from and when, that it went through your personal mind and landed on the page. The litmus test of actually a good exam. So there's 1,000 ways to write a good exam and to get a good grade, right? And they all come down to authenticity and honesty. And I do see there's something in the chat, and I do see I'm taking too long. And even if we don't get to the 1D problem, I mean the 2D problem, like I hope we do, but even if we don't, it's okay, because we have to get this out of the way finally, like it's time. What I'm saying is, and we'll talk more about this, but what you're trying to show in your exam is that you actually get the stuff. You're not allowed, it's not cheating if you go on the web while you're taking the exam. That's just not cheating. And it's not cheating to have your friend sitting next to you while you're taking the exam. That's not cheating. What's cheating is writing down something that you don't understand. And the 2 things about that are, or the 3 things. 1, how do you demonstrate that you actually understand? You use as many colors as you can. You make as many diagrams as you can. You use as many words as you can that are your personal words in English, or if you speak another language, add the other language too, whatever. You show me that this stuff is filtered through your personal mind and your personal perspective. You do as much as you can to personalize, to actually put the stamp of your mental understanding on these things, right? And where you don't understand things, you be as honest as possible about that. Number 1, that's number 1. Number 2, and I do see there's stuff in the chat I'll totally get to in a second. Number 2, how do you know when you're doing that? Like if that's what I'm looking for or not? What you do is you constantly ask yourself, if I were in Yavrom's office right now and he were asking me about my work, if you were asking me, not like, where did you get this, but just like, why is this true? Why is this true? Why is this true? Could I answer his questions? You're thinking of yourself as making a document that you could defend to me, that you could defend the sense thereof, right? So your exam is to prove that you understand this stuff. It's not to, okay. We'll talk more. There's one other thing about that. And I want you to know, like, I know, like, okay, I'm going to get too far into, but that's how the exam works. So we have to have one. And that's, by the way, that's also the way the final exam works. Literally, that's how the final exam works. Fully take home, fully open universe. But your job is then to produce a document that shows that when all was said and done, when you sat down and put pen to paper, your pen was writing things that your mind actually had eventually internalized and processed. Like, that's what you're showing me. And I can tell, and we'll get into this, but believe me, I can tell the difference. Like, so I'm saying a lot of things that you think of as cheating are not cheating in this class. But I'm also saying, oh, there is a concept of cheating, and it may not be what you ever thought was cheating, but there is a concept of cheating, and every semester a couple people do it and they suffer for it. Like, your concept of not cheating, you can do anything you want except for write down things that you can't actually defend. Now, that said, I'm going to look in the chat in a second, but in case we run out, because I could see, in case we run out of time, I will look in the chat. And I don't mean to be yelling, but I know, like, exams make me as nervous as they maybe make some of you. I do all this to, once I get this out of my mouth, like, hopefully this is not a trick. Hopefully this will make the whole exam at least a much more fair, transparent process for a lot of you. Like, even though you'll still have to actually authentically struggle through the physics material, hopefully that's the only thing you'll have to struggle through, not all this other extraneous psychological stuff. Okay, that's like the idea, is just to really just be dealing with what, as hard as physics itself is. All that said, I believe I will look in the chat, but so it means that from the moment I announce this, which is now, we kind of usually need like 2 weeks to prepare for the exam. I'm not saying the exam is tomorrow or something. What I'm saying is, I guess and I'm not looking at a calendar. So this is what you're going to have to discuss in the breakout rooms. Because I know Thanksgiving is going to come into this and it's going to get all, but I believe that I think we should shoot for that I post the exam. I think I want to say 2 weeks from tomorrow is when the actual exam's posted, which would mean, wait, is that right? Wait, is that, hold on, sorry. Well, this is what I guess we'll discuss in the breakout rooms. Either way, you'll get a practice exam in Google Classroom before the actual exam. So one way would be that the exam is posted 2 weeks from tomorrow. But again, I don't know if that gets into Thanksgiving or what. You'll have to check. And if it were 2 weeks from tomorrow, then the practice exam would be posted like in the middle of next week. Or if that gets into Thanksgiving and stuff, and we certainly don't want this exam like right before finals, then the other thought would be that it gets posted on Thursday, that it gets posted a week from tomorrow. And then you have till the following Monday to give it back. If I did that, then I would post a practice exam this weekend. And then we would be able to talk about, then you could be working on it. And certainly by Wednesday, the day, and we would certainly talk about and answer questions and review like the Wednesday, the day before the actual exam was posted. And you could still ask questions even on the Monday. But in fact, and honestly, as I'm thinking about it, that's probably better even for you guys. Like, so you'll have a practice exam, you'll see it before the actual thing, and the actual thing, you'll have a full weekend to do, and you'll do it fully open notes and all that. So as I'm talking, I'm kind of recommending maybe that we need to get this. I'm recommending that maybe you think about having this thing be posted a week from tomorrow, but you negotiate in your rooms. If you all decide that it's better for it to be posted 2 weeks from tomorrow, and that doesn't get into your Thanksgiving or get into other things, I could be open for that. Or if you have some other version you want to propose, but that's the basic idea. And that's what we kind of have to, but I want you to have input in this. I'm not trying to just spring this on you. So that's what we're going to have to resolve in a minute. So even if we don't get to the problem, which is kind of annoying, but even if we don't, we don't. But let me look in the chat. I see things are happening in the chat. Hold on. Okay, so will there be an answer? I understand. Oh, great. Oh, thank you, Caroline, for saying that. No, actually, that's awesome that Caroline said that to the group, really, because good. Because it is unusual what I'm asking for, but good. If you get, then I believe Caroline too, and that's great. Wait. Oh, and then someone's in the direct chat. I should address this. Oh, okay. I answered it. Okay, fine. Someone had a good question in the direct chat, but they're saying I answered it. Okay, cool. So wait. Oh, wait. Now Samuel's question is a really good one. So but I think everybody can see it. Samuel's saying, so on our final topic of the exam or final draft of the exam, we write answers to only questions we understand, know how to solve. Oh, no. Okay. That's a very fair question, but let me be more clear. No, I'm not saying that. I'm saying when you do the final exam, when you do the final draft of the exam, you are going to do the whole exam. You are going to do the whole exam. Now, it is possible. Sometimes I give choices. Like sometimes as an instruction in the exam, sometimes I might say, you must do problem 1 and 2, but then choose between 3 and 4 or something. Like if I say that, then you do that. But no, I am saying that you have to do I know why Samuel is asking this. I am saying you have to do everything. But what I'm really saying is I'm looking for authenticity. So what I'm really saying is anywhere you know it all what's going on, anywhere like you have the answers and stuff, what you want to do is put all your effort and energy into really expanding and really including every single step and really justifying and really explaining. In other words, if you're doing something out and then you're like, oh, and then I divided both sides by 2. Does he really need me to say that? Does he want me to say I divided both sides by 2, or is that obvious? Anytime your brain says that to you, like, should I include this step or is that obvious? What I'm saying is, no, include that step. If you can even think of a step that your brain did, write it down. Like you want to show me every little justification and every bit of actual understanding that you did. You want, especially things that you think you get, you want to super over explain them. Now, at the same time, what I'm saying, here's Samuel's question. There might be parts where you get it, where you think you get it, where you know you're not cheating, but you're like, but your grip is a little bit more tenuous. Like you get it, but you don't have as much to say because you're still kind of just getting it there, especially if you've already gone to town in other problems and you're like, boom, 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 step, step, step. If there's a place where you're a little bit weaker, what I would love you to do is instead of just copying down an equation that you know is right, but you have no idea why, write the equation. And then if you try to understand it. But if you can't, then at least write in the margin something like, I'm not really sure where this V0 came from, but it's right. Like I'm saying, be as honest. Your whole deal is to be as honest. You're trying to give me a snapshot of your brain on all of this stuff. So wherever your understanding is more fragile, it would be better to admit that it's fragile than to try to compensate by like adding more equations that you got from the web or something, or that your friend, don't try to impress me with over knowledge. Impress me with honest self-awareness. So Samuel's question is really good. I'm not saying leave things out. Like, no, you don't want to leave things out. You don't want to leave blank spaces. But I'm just saying wherever what you're writing is a little bit weaker, admit that it's weaker. Admit that you'd have, or literally last, like say you're doing a bunch of things and there's like one part where no matter what you do, you just can't understand this like one detail, but you know it's right. And you've racked your brains around it and you need to go on. So on that one part, be like, I know this is right and I need it to go on and everything else is good, but I've never understood why there's a minus sign here. Like, I know I need the minus sign, but I honestly, for the life of me, I cannot, like, you can write that. And I would really respond well to that. So that's the kind of thing I'm like, it's like a report on your understanding, really. Okay. So I think hopefully that answers, I know, okay, it's 1:18. We're gonna have to resolve this. Wait, yeah. So what Nicholas said, I'm understanding. Yeah. Right. And then Caroline. And so what Nicholas wrote in the chat, and then that Caroline did that thing that means like facts or whatever, like that further confirms that when Caroline said earlier that she knew what I was talking about, like clearly, yes, what they're saying. But it's a real deal. Like, well, anyway, yeah. No, I do. Yes. No. I really am. Someone asked us in direct chat. I really am looking for the 5-step. Look, there's other ways to do these things, but they're more risky. The safest thing is to go to town with the 5-step method. And it's even safer if you even want to label your steps as you go. Like, I'm not saying it's literally a rule, but that would be the safest way to show me that you know what's up and to make it easier for me to follow. Fair question, but yeah. So to Samuel's question, the way you show you understand is by explaining as much as possible, explaining your steps as much as possible. And that means including as many steps as possible. Go as micro as you can. Like literally every step you do, right? Every step you do, if then it occurs to you like, wait, okay, so then I like, like literally I subtracted 4 from both sides. Does he really need me to say that? Yes. If it cursed you, that it was a step. Say it, but then also the other way you really show that it's you, and some of you know this, or I know you know this from your homework and stuff. Some of you really like once the way you manage your work in school is you because it's like the way you some of you take like command of your work and take stress out of it is you have your own little methods. Like you either use unlined paper or you use like colored magic markers or you draw little doodles and cartoons, like stuff like that you should do. You got to make this, like you want to own this. You could even think of it as a little mini poster presentation or whatever. Like the more you can really show that it's gone through your mind, the better. So yeah, annotations, explanations on the side, extra diagrams, anything, anything to really show that you get it. The looser you can be with it, better. Okay, but the 5-step process, yes, as Nicholas says, is basically, okay, I'm looking at the time. I love what this is good. Yeah. Oh, so wait, so now Felicia's question is the question. Felicia's saying, can I clarify exactly? Well, I can clarify what I'm suggesting, but you guys are ultimately, it could be your decision, which is why we're going to, no matter what, we have to resolve this before this period is over. But even if it ends up not being a breakout room, we're going to resolve it. So, oh yeah, wait. Okay, wait. So on Elda's thing and Felicia's thing, a great place to end. Well, I want to resolve the date right now. But I want to make sure it works for you and you don't all have an orgo test the same day or something like that. So I'm looking. Okay, wait. Okay, just because it's concrete and it's in the thing. I mean, it's in the chat, thanks to Elda and Felicia. This might be the most concrete way to go about this. Here's what I'm going to do. That's the proposal. And now I'm not looking at the calendar. I don't remember. Oh, I guess Thanksgiving's later. Okay. I think, yes, that is my proposal, is that I release the exam Thursday night, November 10th. Right. That is my proposal. And then it would be due back 12:15 p.m. Monday, the 14th. Right. Yeah. That's my proposal. I'm going to walk to save time or whatever. I'm going to walk away from the screen right now, honestly. And I mean, really, I'm going to walk out of earshot. I'm going to turn on whatever. I'm going to turn off my speaker. I'm going to walk away for like 3 minutes. You guys discuss this as a group. What the part you're discussing is not the rules or anything like that. You're discussing if that date works for you, within reason, like assuming we have to do this, right? And that's the way it works. So like the only other alternates would be like a week earlier, or I guess a week later, but that's crazy because of Thanksgiving. So just confirm as a group that that date is clear to you and works for you. And if it is, I'm going to come back and we'll seal the deal. But I do want to give you an opportunity again, in case you all have an orgo exam or something like that. All right. But that is the proposal. The thing, look in the chat, what Elda said. Yes, that would mean I would release it at 8 p.m. November 10th. You would have the full weekend to work on it with friends, with the internet, blah, 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 with solutions to a practice that you already have in your possession. But then you have to spend that weekend actually understanding the material and demonstrating to me that you actually get it, which means like it's a very thorough document that you hand in, right? Like you should do drafts of it. It's like an essay in that sense. Like you're not just scratching out answers. And yes, it's all about your work and your process. Yes, it's not just about your final answers. I'll tell you this, if you do so yes, even if you get a final answer wrong on something, you'll still get tons of points for all the other stuff you do. The truth is, if you do all this stuff this way, most people do end up getting the right answers anyway, if they do it all right. And that, it doesn't, but yes, it's not about answers. It's about process and presentation. So, okay. Oh, thank you. All right. So I'm going to walk away. We only have 6 minutes. So I'm going to walk away for like 3 minutes, like but come to some kind of thing, and I'll be back. I'm going to turn off my speaker. Well, you can't tell, but I'll turn off my video so you know. Okay. Well, no, I'm leaving the video so you know I'm walking away.
Does that time work for everyone? The 10th to the 14th? Because I feel like we all just took an orgo test either this week or already passed, and there's no other test during that time. Unless you guys have tests for other classes.
That works for me. Works for me too.
Works for me.
All right. Is that everyone?
I mean, we could all just raise our hands.
Yeah, you want to raise your hands if it's fine. Okay, I think that's majority of us. I think we're good then.
I guess we're not doing the example problem anymore.
Okay, hello. Oh, okay. Oh, cool. Oh, okay. Sorry, I'm back. I'm back because, but, and I know we have like 4 minutes. Wait, why does the chat look weird? Is there, so do you have, can you hear? Oh, David Pinder has his hand. Oh, is that a hand for me or from?
That was from before. We said that the 10th was fine and then do on the 14th. Majority of us agreed.
Oh, great. Okay. Thank you so much. Okay. Thank you for that clarity. So that's great. And even if and we'll get back to the vectors like somehow, but that's great. I will post this, like I will start posting things in Google Classroom to make this clear. Like there'll be one of these, like, well, I'll put these details in Google Classroom so they're clear and they're written. I appreciate all your input and your feedback. It seems like we're all on the same page, but let me also say now, and this is also just true in general. I am, how can I put this? Once the exam happens, like, yes, I am strict about the timing. Not with homework, I'm not. With the exam, like you will have to turn it in on time and you have to show up to class today. But, like everything else in life, or at least for me, of course, there are exceptional circumstances. Of course, things happen in people's families and jobs and blah, 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 blah. So first of all, it's always the case that once the exam starts, like it's possible that someone could have a circumstance. And if you reach out to me during that weekend and you say you have a circumstance and that you need more time or something like that, usually I can be very accommodating, even if it's personal and you don't want to get into the reasons. I don't need doctor's notes and things like that. But the thing will be that you have to communicate with me. As long as you communicate, then we'll be able to work out something. There's a reason I'm saying this, but the one thing I'm totally don't tolerate, the one thing where I'm surprisingly strict, so I want to warn you because you wouldn't expect it from other things, is that anybody who literally does like a no-show or like just hands it in late without ever asking, or doesn't show up to class that day, or just doesn't follow the rules and doesn't ever reach out in advance, that's bad. And that has bad consequences, just to, okay? It's not true of homework, but it is true of exams. But the other thing is, since you just took a vote, or since the word majority was just used, I also want to say to anybody that was outvoted, like this is not actually meant to be like oppression of the majority or whatever. So anybody who didn't like that timing or has an issue, you guys, whoever you are, can reach out to me personally later and we might be able to work something out. I need to know what I'm doing for the system of this whole group. And now I know, but that doesn't mean that I can't accommodate personal okay. And this is true for everybody. If you happen to be on the upside of the vote now, good, but there's going to come a time with the final exam or in physics 204 where you might need an accommodate. So Every individual is an individual. I'm just saying, if you just got outvoted, don't walk away from this class all resentful or pissed at your colleagues. Like, we might be able to make an arrangement if you communicate with me, whoever you are. Why I'm saying all of that and why I'm doing all this. And I know we're going to go in a minute. Sorry, we didn't do the vectors. It's okay. Well, I'll figure out what to do about that. And there still might be a homework assignment posted soon, by the way, that's just to keep us rolling, because we still now have 2 weeks for this exam. But the last thing is why I'm doing all these things. And you'll hear more about this later. It's not just because it's not because I'm a pushover. I mean, maybe I am, but that's not the reason for all this. Part of the reason I do all these things is that what I really believe is that nobody can get through physics alone. Certainly not me. I could not have gotten through college physics or graduate school physics by myself. No way. I don't know anybody who does. Plus, it's not fun to do that. I think that at John Jay, anything I can do to get you guys to help each other more and work together more and compete less is to everybody's ultimate benefit. So that's also why I do things this way. I don't want you to be pissed at each other, and I don't want you to take unfair advantage of each other. I want you to help each other. And that's also why my whole policy on cheating is the only thing that's cheating is to have an unfair advantage over your colleague because your colleague actually did the right thing and you decided not to. But if I make this whole thing open universe and everything as I'm doing, then you all have all the same advantages. So it's not cheating. You'll follow, okay, and we could talk, but my point is, please make a group chat if you haven't already, or like a Discord or whatever. The more you can help each other, the better for all of us. And your A does not get threatened by somebody else's A in this class. Okay. Okay. So I'll get to the vectors later somehow. There will be a homework assignment posted. Thank you guys so much for. Oh yeah. Wait. Okay. Sorry. You could go, but someone had a direct chat question. Right. Direct chat person. Right. As long as you tell me in advance, just if you can't go to class that day, as long as you ask me in advance and I agree, then you're fine. I just don't want to be surprised that day. Right. So direct chat person, maybe you can acknowledge if I just answered your question or not. But yeah, like things can be arranged as long as they're arranged and communicated. Have a great day, guys. Okay, wait. Direct chat person, did I answer your question? Or
Have a great day.
Oh, have a great day. Have a great day. Oh, okay, great.
Bye,
Okay.
Professor.
Have a great day. Okay. Have a great day. Okay. Okay. Have a great day. Have a great day. Oh, Felicia, you're good? I mean, you're the only one that I'm not recording. Wait, I'm not recording. Wait.